Look, firstly, thank you very much. I'm delighted to be here today, and on behalf of Rio Tinto, thanks to the conference organisers for inviting us. Look, I'd just like to start off by saying something that I think is obvious, in that Rio Tinto doesn't claim to have the exclusivity on innovation in the mining industry. Innovation in mining has been with us from the day that the first people looked at rocks and said, there's something in there that I want to extract. Innovation is driven by the requirement to drive productivity, to drive output, and to combat the natural nature of our business, which is entropy. Mines get older, challenges get more robust as we go on. Now, Rio Tinto has taken a different view on innovation that I want to share with you today. We've made some announcements over the last probably 5 to 6 years on work that we're doing. I'm going to try and place that in context, try and explain why we're doing what we're doing, and then I'm going to look at the surface mining area of our work and explain that in some more detail. So why do you do this stuff? It's really simple. Improve productivity. That's not new in the mining business. That's been with us. I think the first mining textbook was one called De Re Metallica, written in the 1500s, and we have a copy of the Latin version, and I actually have a copy of the English translation of 1912, I believe it was. If you look at De Re Metallica, the push in those days was to improve productivity using new machines, using new exploration approaches. This is exactly what we're talking about today. Improving productivity in the mining business is just simply good business. We view the work that we do as a good investment for Rio Tinto. It's a good investment for our organization to pursue, and the investments we make in step change innovation that I'll discuss stand alongside the investments that we make in exploration and the investments that we make in capital projects, and it's viewed with the same light. We've got three, let's set some ground rules here. We look at innovation in three ways. None of it is new. The first innovation is continuous improvement. That's been with our industry from day one. Businesses to survive today continuously improve. We look at the way we do things. We want to make things work better. The second way that we look at innovation is incremental. Incremental innovation is provided to us, generally from the marketplace. It's delivered by all those vendors that we hold dear and that are close to our industry. What Rio Tinto invests in, and what is my job, is to target specific, very hard problems that if we crack them, and the question that we ask is, what can't we do today that if we could do tomorrow would fundamentally change the business? We take the risk, we take calculated approaches, and we make specific investments in mining and mining-related technologies to bring to our business. So that's kind of my job. That's the Step Change Innovation Challenge. Why do you do it? Now, I'm not here to push the Productivity Commission statistics because they are quite arcane, to be honest with you. This is a report that was published in 2008, and I think they really need to update it. The Productivity Commission looked at the extractive industries, and that included also oil and gas. And it said for every unit of output, what is the unit of input? So it's dividing the outputs by the multi-factors, the inputs required to achieve the output. And as you see for Australia, we've been on a decline, and that shouldn't be surprising. Ore bodies get older, haul distances get longer, the mineralogy that we're extracting resource from gets more complex. This is an inevitable decline. It is entropy at work. It's what we face every day in our business. What we need to do is apply technology, apply new thinking, apply the next generation of tools and systems to try and arrest that decline. That's a total Australia picture. If you want to go into the arcane science of how they came up with those numbers, it's on the Productivity Commission website. It's a very interesting report if you're that way inclined. So, what can one declare? What can one conclude from that? Absent big, significant Tier 1, Tier 2 deposits, that come with naturally advantaged topography and mineralogy, that decline is with us. We have to fight that decline. Whilst that's a challenge, it's also an opportunity. One of the arguments I'll put forward is that's a great opportunity for Australia, for the mineral supply industry, for the technologists that support our industry. It's a good place to invest your money to try and arrest that declining problem. We live in interesting times. Notwithstanding the current, I used to go to Greece I've been to Greece 3 or 4 times on holidays. I don't think I'll go back there. Look, we're living in interesting times. The markets have been coming down. However, look at our industry. Look at that behind me, sorry. That's what's happened in 25 years. We live in a time of the greatest translation of people from the rural environment to the urban landscape. If they're going to move into the urban landscape, they require minerals. They require what this industry produces, but also all our competitors on a global basis. This year or next year, China goes 50%, so 50% of the population is living in the mega cities. India is coming along. You've got the rest of Asia. This is underpinning the context of our industry, but we have to ride through the financial turmoil and the ups and downs that we currently see in the marketplace. That is the nature of our business. So, being an optimist and also being a realist, this is a good picture for our industry. The demand situation looks like it's going to be there for a while. It's going to be there for the long run, and we have to bring material to the marketplace, and we've also got to fight that multi-factor productivity decline, which is endemic in our industry. It's also endemic in the nature of the more mature industries around the world, such as the Canadians. They have exactly the same problem. So that's productivity, demand, supply. There's just a couple of pictures there. There's also challenges for supply. Look, we've seen mature ore bodies come and go. The ore bodies that built Sydney, New York, Paris, London, they've probably done their job. The ore bodies that's got to build up the New Bombay, the New Delhi, Western China, they've got to come online and do their job. So we've got mature ore bodies. If you look at the copper challenge and you look at the way that copper's been discovered at depth, we're going to be going underground. We're looking at rock factories of 150,000 tonnes a day, 2 kilometres underground, 1 kilometre underground. That's where the next big copper deposits lie. We've got lower grades, we've got longer haul distances, and we've got some complex mineralisation. We also have the stakeholders and the shareholders quite rightfully saying, hey, lower your environmental footprint. Do that within a carbon-constrained world. So these are all issues that we have to face. That's fine, and technology is part of the way that we're going to face these issues. We have to grab hold of that technology opportunity. We created the Mine of the Future, and I was lucky enough to be asked by Tom Albanese to start this venture, probably 2006. And it's a concept and it's a vision. It's basically saying, look, there will always be a mine of the future, just make it happen a lot quicker, please. How can we tackle that? What can't we do today that if we could do tomorrow would fundamentally change the business? That's what drives my thinking, and if you think about the world in that way, the actual questions become quite small. In fact, you can fit them on 2 pages of A4, but I won't tell you what the questions are. So, how are we going to exploit the resource? How are we going to go underground? How are we going to recover more from increasingly difficult ores? And the underpinning philosophy in our industry is safety, 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 and then safety. How do we make this world that we deal in inherently safe? We deal with massive energies, and we have humans close to massive energies. We have to be very careful, and we've got to engineer in safety. So that is the Mine of the Future as a concept and as a vision. What I'm going to walk you through in the time that we have remaining, and I'd like to have time for a little bit of a video at the end. After we've talked about the technology, I'd like to show you something about people, because people run operations, robots don't. Let's start going a little bit into how we work, and then I'm going to go through the surface mining operations. This is a challenge for us in Australia, but it's also an opportunity. Excuse me. If you're going to tackle those questions, what can't you do today that if you could do tomorrow would fundamentally change your business, you've got to find the best minds, with a D, not an S, the best brains to work on these fundamentally quite difficult problems. Fortunately, there's a lot in this country. Also, we live in a Google world. I guess for people here who have children of teenage age, Facebook, Google, interconnectivity, we can have people spread all over the planet working in teams as if they're in the same room. So we know that in our culture, within the Rio Tinto culture, which is an investment culture, which is a productivity-driven mining culture, we can't do it all ourselves. So we've created a network of alliances, a network of people, a network of some of the smartest colleges in the world, and we've pulled them together into the innovation network. So we can offload robotics problems now to Sydney. We can send our metallurgical problems up to JK. If we want advanced chemical engineering or mathematical problems, we go out to London, to Imperial College. And for underground, for that very hard geotechnical challenges we get deep underground, we'll go to the Nickel Rim area up in Sudbury, because that's a pretty difficult part of the world to go underground. So think about this as also an opportunity for Australia. We have great technologies here. We have some great companies here. You can compete on a national scale and also on an international scale if you've got comparative advantage. The modern world allows you to do that. Innovation is truly a global game. You've got to ask yourself, why do we do this? We don't set ourselves up with the aspiration within Rio Tinto to be the research and development engine of the rest of the industry. We participate in many collaborative ventures, but in those areas where we choose to attack a specific deep problem, and we do expend significant amounts of our shareholders' money, we protect that intellectual property heavily, and we make no bones about that. However, please look at this in a holistic sense. As we've done with our operations centres in Western Australia, yes, we've protected quite a bit of that and the details of how it works internally. But when the outside world sees that it can be done, people will start to follow. They'll find different ways to achieve the same outcome. You'll create new industries, new suppliers will come along. So we make no bones about doing this for our shareholders. You cannot expend the significant amount of resource that I expend on an annual basis without holding it to the corporation. However, over time, all knowledge goes to the market. Patents expire, and this will become the new way of doing things, we believe. So let's look at some of the areas. I'm going to take you on a journey in the surface mining story in the 17 minutes that we've got left. There's kind of four things that I do. I look at the world in terms of surface mining, underground mining, recovery, and we have a background program that's been in the business for a long time on exploration. That's a gravity gradiometer. So finding the next tier of ore bodies, what specific big questions can we attack, and one is flying a 1 ATVOS gravity gradiometer at 150 meters above the ground and being able to see those signals 2 kilometers underneath. We think that's a really hard task. It's orders of magnitude above where contemporary instruments will do, and we've put a lot of resources into that. We talked about developing future block caves. I see that Olympic Dam, that was a great number, 300 kilometers of tunnels already. To bring on a new block cave, 1 pound of copper in a mega block cave, this thing may be 2 kilometers under the ground, it may be at 85 degrees rock temperature. You're probably up front 75 to 100 kilometers of tunneling before you get $1 out of this thing. Okay, and typical block cave advancement rates on these tunnels are about 4 meters a day. So that's using traditional drill and blast. So how can we fundamentally change that? We've gone to the civil industry, we brought over mechanical excavation tools and techniques, built processes, and we're putting the first of the machines underground actually in North Parks, and that will go underground September, October time. Mines, I'm going to talk about the surface mining approach, and that is we want to run the surface mine with the same kind of precision as Toyota runs its car factories. And there's a way to do that. I'll cover that in more detail. Recover, you may have seen in the press our sorting announcements. We are chasing sorting on a massive scale, absolutely massive scale. We have pilot plants that have run their course in the iron ore business. We're very active in copper, and we're looking at other minerals, bringing in technologies from food and waste treatment industries to pre-concentrate or scavenge minerals from the feeds. Let's have a look at the surface mining. One of the messages I want to give you is that when you put your mind to this stuff, it can happen quickly. And this is just a little time slice of the journey in surface mining. We started this work in 2007. And in 2007, we started to run one pit in an office block in downtown Perth. And that was the very early days. Then we started to run the Eastern Pilbara in downtown Perth. In 2008, we entered into an alliance with Atlas Copco for drills and autonomous drills. Remember, the most interesting piece of information you will ever get out of a surface ore body is the amount of drilling that you do before you blast it. In the Pilbara at 300 million tonnes a year, which is where we're heading, we will drill 1 million blast holes a year into that ore body. Think of the opportunity for data. Think of the opportunity for driving in process control. Once you have autonomous drills, you can start to put very clever, smart systems on them. We started that journey in 2008. 2008, we tested the first autonomous trains up and down the Pilbara operations. 2009 was a watershed for my group. We built the first autonomous mine, and that was Alpha Pit, A Pit, in the West Angeles deposit, where we brought in autonomous trucks. We brought in the autonomy from our drilling solutions, and we started to run that remotely. 2010, pulling data off the drills to understand the geology in real time. 2010, the operations center was commissioned, and I'll talk about the operations center. And then we go to autonomous drills. We've committed now, after the A-Pit trials, which ran for, we moved about 55 million tons under autonomy, and then we committed to 150 autonomous vehicles in the Pilbara. Cabless drills, autonomous train deployment has been announced, and now we don't want to put humans into the pit when it's 50 degrees centigrade to do the surveying. It's easier to do that with a standalone, either with a drone, with millimeter accuracy laser, or drive through the pit with Land Cruisers to take pit shells in real time, so you understand what your survey picture is. This happens quite quickly. All we have done in Rio Tinto is accelerate this. We brought this thing forward. Just picture the traditional mining on the surface. You do your geology, exploration. You do the work to prove up your ore body before you move it into production. You do the production drilling. You do the blast hole drilling. You then load explosives. You then blast it. You then convey it. You then crush it. You may put it through some plant. You move it down a railway line. You mix it in a stockpile, and you sail it off to the customer. Every single one of those steps is a batch process. It's a standalone process. The data flows between those steps are where the opportunity for productivity lies. If we can integrate the data and integrate the operations and add autonomy along that vast supply chain in real time, we can start running these mining operations with the same kind of precision that you see, say, in a Toyota car factory. That's closing the process loops. That's the vision for the surface mine of the future, which is a data-rich, which is megabyte-driven, which is high levels of autonomy and high levels of productivity. In 2007, we opened the operations center, and this was driven by iron ore. It was a watershed moment for our company, a watershed moment for me. We have 14 mines in the Pilbara. We have 31 pits. We have 1,500 kilometers of rail. We have multiple power stations, pumping stations, water reticulation facilities, and also 3 ports. All of that now is run from Perth. That's 1,500 kilometres away. We have 2 dedicated fibre optic lines. It came online, remember the early work was 2007, 2006. It came online during 9, 10, and now it's in its 2nd generation. When you make those changes and you say, what can't we do today that if we could do tomorrow would fundamentally change the business? Well, running the business from one place is a pretty good place to start. It really is. You can start to drive out those inefficiencies. Others are starting to bring these things online. Remember the story? If you prove that it can be done, others will come. And while some of this technology we hold proprietary, others are going on that direction, and that's fine. By the time they move in and turn on their operations, we'll be in it for 5 years. And the job for Rio Tinto is to keep 5 years to 10 years in front of everybody else. From that experience, we started to build the second concept center that's being built as a pilot because we're taking a little bit of a different twist to the building of the next one. That comes online this year, and that will be on a truly global scale. So we'll be running operations globally. Why do you do it? Well, you do it because of this. Variability in that end-to-end bulk mining process. We could have a deep dive, say, into lead zinc concentrators if you want, but let's stay up here for a while. End-to-end variability actually is the enemy of efficiency and planning. Schedule variability. How variable is the schedule along the system from the front of the process to getting it on the ship? Well, since we brought online the operations center, we've pulled out well over 40% of schedule variability, and we've managed to hold it. We think we can take it down even further. And that's driven, at the bottleneck, productivity increases of about 31%. So just driving those systems, running them with a new paradigm in the mining in the industry, we think this is a good investment. That can be done everywhere. Don't underestimate the power of these technologies. These technologies will also come down. They will start to be available, I imagine, to most mining companies over a period of time. So, we've got a little bit of time left, and I do want to run one video. I've stayed at the top of, and I do want to leave some time at the end for questions. Typically we get a few. We stayed at the top, and we're saying, remember the productivity challenge, we're hitting it with autonomy. We're still employing a lot more people. We can't get the people to run these operations as we would like to, and we're expanding all the time. Think about it as efficiency of the process. Think about the mining industry taking a step change improvement in its efficiencies and driving up productivity, reversing that multi-factor productivity decline. That's why you make these investments. Also think about the secondary industries that spin around and spin and circle our world. We have an interesting world, but outside there's a whole magnitude of suppliers of services and technology to the mining industry, and a lot of those are domestic Australia. I've supported for many years I guess it's a government initiative called AusMine, which helps these technology suppliers get into the export world. If you don't know it, go to the AusMine website. That's a fantastic story. That's a secondary industry being built from our mining industry. These people are building the next technology set of solutions. They're small and medium enterprises. They're exporting. They're exporting billions of dollars, and they're creating the next set of jobs. So Australia has a comparative advantage because it's got all of the mining companies here. We have a great educational system. Hopefully the tax system will not choke us down. We need to continue the investments in these technologies, and we have the opportunity to build on a world scale a comparatively advantaged industry, which is in mining, technology and services, and others will do that. That will be to the benefit of all of us. I notice I've got to leave here. I do apologise. I've got to get back. I've got meetings starting first thing in the morning. There is a panel meeting, a panel discussion at 4:30 on on rocks and crops. I hate the whole concept of rocks. I think it's quite demeaning when you hear politicians say, well, we're just rocks and crops. Think smart rocks. That's the future. We've been hidebound with productivity, dollars per ton, tons per shift, utilization, availability of equipment. The next frontiers are going to be something like megabytes per ton, MIPS per ton, AIs per process, artificial intelligence modules. We're putting those things in. Outside of that concept is the opportunity for a great export industry. I'm delivering this very same message to Canberra next week, and I believe some of the senior politicians will be there. Before we get to questions, we do have 5 minutes left, so I've kept to my promise.